All right, today we are going to look at position versus time graphs and how to actually translate a position versus time graph into some words. Okay, so the first thing we need to be able to do is understand what it's telling us. So the first thing is it's a position versus time graph. So it's telling about the position at any given time. So I can see that the position starts at a positive number, becomes more positive as time goes on, and then over time it eventually becomes a negative number. So it moves to a negative position. So you can imagine a dot moving on a number line. So it tells us a lot more information than just where something is at any given time. It also tells us these things, and so I'm going to walk us through these. So for position versus time graph, where the intercept is tells me about the initial position, x naught. So for instance, this one has an initial position of some positive value. The slope also tells me about how the position is changing with time, or rate of change of position, which we know as the velocity. So at any instant, I can tell you something about the velocity. So for instance here, the slope tells me about the velocity. Same here, same here. Everywhere that slope is telling me about the velocity. The steepness of the slope tells me about the magnitude of the velocity. And we know the magnitude of the velocity to be the speed. Whether it's a positive or a negative slope tells me about the direction. So let me explain that to you here. So on this portion, it's uphill. That gives it a positive slope, meaning we have a positive velocity, meaning my object is moving in the positive direction. Here, my slope is 0. So my object is not moving at all. And then here, the slope starts to become negative. This whole way, it's down slope. So the negative means the object is moving in the negative direction. Concavity. Concavity tells me about the acceleration. So as the slope changes, we'll have a curve. And that curve tells me about how the slope is changing, or a rate of change of velocity, which is known as acceleration. How much it's curved, so the curvature tells me about how the magnitude of the acceleration, and if it's concave up or concave down tells me about the direction. So let me just kind of show you what I mean by slope, or instantaneous slope at a point, and concavity. So if I take a curve such as this, and I say I want to find the slope at this point, what we do is we take a straight edge ruler, whatever you imagine, and you pretend like you are going to create a line that's tangent at that point, meaning it only touches at that one point. And so that blue line I just drew here is the slope at that point. So that's what I mean by slope at any given point. It's pretty easy when it's a consistent slope, but when it's curving, this is what I mean by a slope at an individual point. Concavity is a little different. So we can remember back that if I have something that is like this, one side is concave, the other side is convex. So when I'm talking about a curve on a position versus time graph, maybe my curve looks like this. I can look at it and I can say, okay, which side is concave? You might say, well, there's a concave section here and a concave section here. You're right. That means it's switched from one concavity to another. That's important. So in this section here, the concave side is on the down side. It's on the bottom. So this area is what we call concave down. This section over here is concave up. Now what that means for me is the concavity tells me about the direction. So if it's up or down, tells me about the direction of my acceleration. So when it's concave down, it's telling me that the acceleration is negative. When it's concave up, it's telling me the acceleration is positive. And if you ever go from a negative number to a positive number, you always have to go through one number, 0. And so right here, where it switches from concave down to concave up, this is the point where my acceleration is 0. This is my point of inflection. Acceleration can also be 0 if there is no concavity. Okay, so an example of no concavity would be a straight line. Okay, so if there is no concavity, acceleration is 0, or points between concave down and concave up. So the next question is, so now I can look at a graph, I can say what the velocity is, positive, negative, or 0. I can look at the concavity and tell you if the acceleration is positive, negative, or 0. I can tell you about the position, but what we want to be careful of is if my acceleration is negative, that's only telling me a direction. It's not telling me if it's slowing down or speeding up. To figure that out, what we need to do is we need to look at the relationship of velocity and acceleration's directions. So if velocity and acceleration are in the same direction, it's speeding up. If velocity and acceleration are opposite directions, it's slowing down. If it has a constant velocity, that's because the acceleration is 0. It doesn't have a direction. Okay? This would be seen as a straight line on a position versus time graph. So how we started here and this top portion here, this little plateau. So the question now is, describe the motion right here at that point. What is going on in that graph? So at this point, I can tell a few things. The first thing is, I can tell myself about the position. The position is on the negative side of my number line. Okay. Well, the slope also tells me something. At this point, my slope is downward. So at that point, my velocity is a negative value. Okay. And how steep it is tells me a relative amount. So I might be able to say that at this point, it's not the steepest point on the graph. So it's not the fastest speed it was going. The next thing I can do is I can look at the acceleration or the concavity. And so at this point, it is concave up, meaning my acceleration is positive. These two things together tell me that it is slowing down. So to put all that together, I can say that my object is at a negative location. It's currently moving in the negative direction, but it's slowing down because it has a positive acceleration. Done.